Monday, Wednesday, and Friday.
Okay, everybody, are you ready for the lecture? Okay, so we were talking about the respiratory system. We stopped here. So today we'll start with the mechanisms of breathing or respiration. Respiration has two phases: inspiration or inhalation of air and expiration or exhalation of air. And to complete one inspiration and one expiration, it takes about 5 seconds. Okay, so one inhalation and exhalation together takes how long?
5 seconds.
5 seconds. So now you tell me, in 1 minute, how many times you breathe? 12, right? 12 times. So that's the rate, average rate of adult respiration. Okay? Now, remember, inspiration is an active process. Expiration is a passive process. So, inspiration is active. Why? Because you need to contract the muscles, okay? Respiratory muscles. Expiration is what? Active or passive? Passive. Normal expiration is passive. Now look at me. When you contract the respiratory muscles, what happens? Your lung expands, okay? Because lung is highly elastic. Lung is what? Highly elastic. So you can expand it, okay? So that is active. You are forcefully expanding it. That's why it is active. Now, after the inspiration, then what happens? Lung stops there briefly and then recoils. That is passive, because to recoil you don't need to put pressure. You know, if you take an elastic thing, you know, you use in your clothes, to expand it you need what? Pressure, right? Pressure. To recoil it, you don't need to put pressure. Just leave it, right? It recoils by itself. So lung is like that, okay? To expand, you need to contract the respiratory muscles, but recoiling occurs due to elasticity, okay? Elastic recoil, passive. Now, what are the respiratory muscles? For normal breathing, the respiratory muscles are intercostals, intercostal muscles, and diaphragm. Okay, those two are the important respiratory muscles for normal breathing. There are a few other muscles. They put little force, but these two are the main ones. Okay. Now, to understand the mechanism of respiration, you need to understand a couple of things. This is a lung, okay, and lung is covered by what? Anybody? Pleura. Very good. So that is the covering of the lung. It has how many layers? Two layers. Outer parietal, inner visceral. goes like this, you see. So it folds here. So this is the outer parietal layer. This is visceral layer. And in between you have a space that is called pleural cavity. You must remember from last class, okay? And inside the lung you have alveoli, million, okay? Okay. Now, the pressure inside the alveoli of the lung is called intrapulmonary or intra-alveolar pressure. Same thing. Intra means inside, pulmonary means lung. Intrapulmonary or intra-alveolar pressure, pressure of gas or air. Okay, pressure of air, which is not fixed. It varies between 759 and 761 millimeter of mercury. That is the unit of pressure of air. Okay. So inside the lung, the intrapulmonary or intraalveolar pressure is this. It changes between that narrow range. Now, the pressure inside the pleural cavity is called intrapleural pressure. Intrapleural pressure, okay, which is always fixed, 756 millimeter of mercury. Okay, so let me remove this. We don't need this anymore. Okay, so intrapleural pressure is what? How much? 756 millimeter of mercury in the pleural cavity here, and the intrapulmonary is this. Okay, so which is more, intrapulmonary or intrapleural? Intrapulmonary is always more, right? So that keeps the lung expanded. That's why lung doesn't completely collapse. Make sense? Pressure inside is more than outside. Is it clear? Okay. Now, outside of the body, the atmospheric pressure of air is 760 millimeter of mercury. That is the atmospheric pressure. Okay? Atmospheric pressure. So you need to know those three pressures. I'm quickly repeating again, okay? Inside the lung, intrapulmonary pressure is what? Fixed or changing? Changing between 759 and 761. Is it clear? Okay. And intrapleural pressure in the pleural cavity is 756. And outside of the body, the pressure is what? 760, fixed. So these two are fixed. Okay. Now, you know that a structure on which the lung sits on, that is called what? Diaphragm. Very good. So your diaphragm is here, and lung is bottom of the lung. The base of the lung is strongly attached to the diaphragm by fibrous tissue, okay? Attached to the diaphragm. So this is the diaphragm. Okay? And in front of the lung, you have what? The chest wall, right? The front of the lung, you have the chest wall. So let me draw that here. So these are the ribs. These are the ribs. and in between the ribs you have intercostal muscles. Between the ribs you have intercostal muscles here. So look at this. In between the ribs you have what? Intercostal muscles. Intercostal. And here you have what? Diaphragm. Make sense? And your lung is sitting on the diaphragm here. Okay. So the parietal layer is actually attached by tissue with the ribs here. Okay. So what happens, you see, when we remember here, the respiratory muscles, I said intercostal and diaphragm. So first let's talk about this one. When the intercostal muscles contract, this is important to know, the ribs move forward and slightly upwards, like this. Forward and slightly upwards. Okay? So all these ribs are moving that way because of intercostal muscle contraction. And when the chest wall or ribs move forward, it pulls the front of the lung that way. So the lung will expand this way. And at the same time, diaphragm contracts. This is important to know. When diaphragm contracts, it moves downwards, not upwards. When diaphragm contracts, it moves down like this. And it pulls the bottom of the lung this way. Make sense? So you see here, your lung is expanding anteroposteriorly this way because of intercostal muscle, and this way because of the diaphragm. Okay? So the diameter is increasing this way as well as this way. So now you tell me, if you expand the lung, okay, we are expanding anteroposteriorly as well as vertically, right? This way. So inside the lung, the space will increase. Space will increase. That will decrease the pressure inside the lung, which is, a common sense. Like if I squeeze something, the pressure inside the air pressure will be more, right? If I give more space, that pressure will go down, right? So lung is expanding, that means inside the lung the pressure is going what? Down. Down to what? This. I said it will stay within this range, right? So it will go to 759. Is it clear? Okay. Now inside the lung you got 759 millimeter of mercury, and outside of the body is always fixed atmospheric pressure at sea level. What is that? 60. So which one is more? Outside. How much more? Only 1 millimeter of mercury. And that is enough to let the air get in. We know this is a rule that air moves from high pressure to low pressure. You know that, right? When the tire of your car punctures, high pressure inside the tire, right? Comes out very forcefully, right? So air always moves from what? High pressure to low pressure. That is the rule. Now, because of expansion of the lung, the pressure inside dropped down to 759, and because of that 1 millimeter of mercury pressure higher outside of the body, air will do what? Go into the lung. That is inspiration. Okay? Is it clear? That is inspiration. So you are expanding the lung by contracting the diaphragm and the intercostal muscles. Okay? Active. Now, after inspiration, then what will happen? As I said, lung is highly elastic, so it will recoil. Now if you squeeze the lung, pressure inside will go up, right? And at one point, it will go up to 761 millimeter of mercury. Now you tell me, inside is more than outside, right? How much? Only 1 millimeter. And that is enough to push the air out. So 1 millimeter of mercury pressure difference is enough to move the air in or out. Is it clear? So that is the mechanism of normal breathing, normal respiration. Now, if I ask you to forcefully expire after normal expiration, if I ask you to blow a balloon, blow a balloon, you have to push more air out, right, forcefully. In that case, is that active or passive? That is active because you are using some muscles, particularly the abdominal muscles and diaphragm, to push the air out forcefully. So forceful expiration is an active process, but normal expiration is due to recoiling of the lung, relaxation of the diaphragm and intercostal muscles. They will relax. When the diaphragm will relax, it will move up. Intercostal muscles relax, the ribs will move down. Lung will recoil easily. Okay? So forceful expiration requires extra muscles. For example, the abdominal muscles are needed. Okay, so that is the mechanism of breathing. Now, okay, so there is a clinical condition. If something pierces through your chest wall and makes a hole in the parietal pleura here. Outside pressure is what? 760, right? Outside of the body, 760. And interpleural pressure is what? 56. 4 millimeter mercury less, right? So forcefully air will get in and fill around the lung. Make sense? Air will get in, and that will prevent the lung from expanding. Okay, so you will not be able to breathe. Okay, that is called pneumothorax. Thorax, air in the pleural cavity. Okay, if someone steps, here, then that can happen, or something, due to accident, something pierces through the, chest wall, that can cause that. Okay. We talked about surfactant before. Let's see, we can start respiratory 2. In respiratory system second part, we'll talk about the volumes and capacities. If your lung is healthy, okay, the volumes and capacities will be more or less? More. Your lung is healthy, the volume and capacity of the lung will be what? More. If you smoke, like you are a chronic smoker, right? That changes the lung tissue. Lung tissue is highly what? I said, elastic, right? But if that elasticity, just think that this way, if the elasticity of your lung tissue is gone, then you won't be able to expand enough, right? So that is unhealthy heart, right? So the volume and capacities will be what? Lower, less. Make sense? So the volumes and capacities are measured to test what? The lung function. These are the tests for lung function. How healthy your lung is. Is it clear? Okay. So there are 4 volumes and 4 capacities. You will learn that. You already know that the pressure difference moves the air from one place to another. So we'll see when the gas exchange occurs, how the pressure difference helps the gas to move from one place to another. Then we'll talk about the factors influence the binding of oxygen with hemoglobin. You know, hemoglobin of red blood cell transports oxygen. So oxygen binds with hemoglobin, and that depends on a number of factors. Then we'll talk about the regulation of respiration. So how many volumes we measure? 4. And how many capacities? 4. Okay. So 4 volumes are tidal volume, inspiratory reserve volume, expiratory reserve volume, and residual volume. Okay, those are 4 volumes. Volume more means not heart, your lung is healthy, more healthy. Okay, now what is tidal volume? Normal breathing. How much air you inhale or exhale during what? Normal resting condition. You are sitting comfortably, okay? How much air you are inhaling and exhaling. That amount is called what? Tidal volume. Okay? Now, when tidal volume increases, when you do exercise, right? The amount increases. Inspiratory reserve volume. Look at me. I am taking normal amount of air, tidal volume, like 500 milliliter. Normal, okay? Now if you ask me to take more, as much as I can take a lot more, right? But normally we don't do. But if you wish, you can do that, right? So that extra volume after normal inspiration, this is important. After normal what? Inspiration, the additional volume you are forcefully taking in, that is called inspiratory reserve volume. That means you have reserved that, right? But reserve thing we don't normally use, right? We keep it when we need. Make sense? That is reserve. So I'm repeating again. Inspiratory reserve volume is the volume of air that we can forcefully inhale after what? Normal inhalation or inspiration. Is it clear? Okay. Like this is your normal breathing. Inhalation, inhalation, exhalation, inhalation, okay. Now if you ask me to forcefully take more, I can take more. So this part is additional volume I am taking. This is normal volume, intake and inhale and exhale. But I can, if you ask me to stop here after normal inspiration, take more forcefully. This is the inspiratory reserve volume. Now after normal expiration, if you ask me to forcefully expire more air out, I can do that too. That is the expiratory reserve volume. Now look at me. I'm exhaling normal amount. I did it, okay? Normal amount. Then if you ask me to do more, forcefully, right? As much as I can expel out. That is what? Expiratory reserve volume. I have that reserve. If I want, I can use that. Clear? Now you tell me. Give me an example. When you use inspiratory reserve volume, when you take a lot of air, say loud.
When you're yawning?
Yeah, you are or when you go underwater. You think you will stay underwater for a couple of minutes, right? You will do what? You will do what? You will use as much as you can to take in. That is the inspiratory reserve volume. Is it clear? Now you tell me a condition when you use expiratory reserve volume, like forcefully expire the air. When? Give me just an example. Yeah. Like, blowing the candle or balloon. If I ask you to blow the balloon, right? You use expiratory reserve volume forcefully as much as you can, right? Make sense? And when do you use both? Tell me. At the same time. When you do exercise, right? You use both. Inspiratory and expiratory reserve. Is it clear? Okay. Now after, look at me. After I forcefully expire the air out, still some air will remain inside the lung that I will not be able to expel out. Make sense? So some amount of air, after I forcefully expire all the air out, some air will still stay inside the lung. That is called the residual volume. Residual volume. That amount of air should remain in the lung to keep the alveoli open. Keep the alveoli open. Make sense? Otherwise, if I expel all the air out, alveoli will easily collapse. Okay? That is one thing. Number two, you tell me, look at it. I have expelled, forcefully I have expelled the air out. I have done it, okay? Would my heart stop? Heart will always pump and send the blood to the lung, right? If no air remains in the lung, then blood will go to the lung but return without what? Any oxygen. Make sense? That is not good. Your blood pH will drop. Suddenly acidosis will occur, right? So that is another very important reason why you need the residual volume. Make sense? Even after you forcefully expel the air out, some air remains in the lung. To make sure that blood is going to the lung, the blood that is going to the lung is coming back with some oxygen. So that is another important. So to prevent the collapse of the alveoli, number two, making sure that blood is getting some oxygen, because blood is continuously going to the lung. So those are 4 volumes. Tidal volume, normal amount of air we inhale or exhale is 500 milliliter. It is same in male and female. Adult male and female, 500 milliliter. Other volumes are more in male, less in female. Okay? At least remember the tidal volume, the amount. Now you tell me why the volumes are more in female, like forceful inspiration, forceful expiration, those volumes are more in male than female. Muscle, right? Strength of the muscle. Okay? So that is the main reason why the volume, inspiratory reserve volume, expiratory reserve volume are more, because male muscles are strong. Okay. Capacities. Just know that the capacities we get by adding 2 or more volumes. How many volumes we got before? 4 volumes, right? So we add 2 or more volumes to get those 4 capacities. So let's see what are the capacities. Inspiratory capacity, functional residual capacity, vital capacity, total lung capacity. So here you see total lung capacity, its name is telling you, right? Total. So if you add all those 4 volumes I mentioned before, tidal volume, inspiratory reserve volume, expiratory reserve volume, residual volume, Add all those 4 volumes together, that will give you the total lung capacity. Make sense? The vital capacity we get by adding 3 volumes, tidal volume and 2 reserve volumes together, give you the vital capacity. 2 reserve volumes and tidal volume. Inspiratory capacity is the capacity that we get by adding tidal volume and inspiratory reserve volume. Now look at me. This is the inspiratory capacity. Capacity, what is your capacity? How much you can do, right? That is your capacity. If I ask you, look at me, if I ask you to take as much air you can, first you will do what? First you will take normal amount, right? Normal amount. Then more. Make sense? So normal is 500 milliliter tidal volume and then inspiratory reserve volume. We are adding those 2, right? First normal 500, then inspiratory. That is my capacity, how much I can take all together. Is it clear? All together. So adding those 2. And functional residual capacity is the air that remains in the lung, not after forceful expiration, after normal expiration. After normal expiration, a lot of air is inside the lung, right? So that includes the expiratory reserve volume and the residual volume that always remains in the lung. Okay? So those are the capacity. We do all these measurements to see the elasticity or compliance of the lung, how much your lung can expand. Make sense? More expansion, more elasticity means tissue is healthier. Now, you know, in some clinical conditions, the tissue becomes what I told you, the elasticity is lost, right? Tissue becomes fibrous tissue, so you cannot expand the lung forcefully, you know, enough. So elasticity is reduced, decreases. One reason is chronic smoking, right? And other clinical conditions like you know, pneumonia or any kind of infection, pleurisy, or can change the elasticity of the lung tissue. So emphysema, we'll talk about that. So again, I showed you here, this is the normal 500, you see 2500 here. That is normal amount 500, 25 to 3. You inspire normal amount 500, expire normal amount 500, that is the tidal volume. Then after normal inspiration again, if I ask you to forcefully inspire, you can take a lot of air inside the lung. This part is the inspiratory reserve volume. Then go back to normal. Normal expiration is here. And then if I ask you to expire forcefully, that is the amount you can forcefully expire or expel. That is the expiratory reserve volume. And still, about 1 liter of air will remain in the lung. That's the residual volume. That ensures that the alveoli don't collapse and blood gets some oxygen when it goes to the lung. Okay, now we are done with those 4 volumes and capacities. Now I'll talk about the dead space. Dead space is the area where no gas exchange occurs. Very simple. Dead space is the area where no gas exchange occurs. Okay. You remember in last class I told you only in last 3 structures of your respiratory system gas exchange occurs, or the gas exchange zone. What are those 3 I did draw on the board? Respiratory bronchiole, alveolar ducts and alveoli. Remember that? So let me draw again. all other structures from the nose to the tertiary bronchiole only for the passes. That's why called the conductive zone. So this is the respiratory bronchiole, alveolar ducts and alveoli. So gas exchange occurs only in these three structures: respiratory bronchiole, alveolar duct and alveoli. Okay, only in these three structures gas exchange occurs. All other structures before that, this is the terminal bronchiole, and from the nose, this is the nose, okay? So from the nose to all the way terminal bronchiole, you have which structures? Let me remind you: nasal cavity, pharynx, larynx, trachea, primary bronchi, right? Secondary bronchi, secondary bronchiole, tertiary bronchiole. All those are for only what? Passage of gas. No exchange. Okay. So from nose to terminal bronchiole only for the passage of air. No exchange. So this is what? Dead space. Make sense? This whole part is what? Dead space. No exchange. Right? So that is called anatomical dead space. Why? Because those structures have been made not to do gas exchange. Have been made to do what? Transport. Passage of gas. Make sense? So that's why they belong to anatomical dead space. If I ask you trachea, it belongs to what? Anatomical dead space. Nasal cavity, anatomical dead space. Larynx, pharynx, all those belong to anatomical dead space, all the way to tertiary bronchiole. Now, so this part is anatomical dead space. They are designed not to gas exchange. Now we know these three structures are for gas exchange. Now look at this. If you are a smoker, chronic smoker, this alveolar duct has been blocked here. So what will happen? These alveoli will not get any air. Make sense? These alveoli will not get any air because of blockage here. Make sense? So this will become a dead space because no gas exchange will occur there because gas is not going there, right? But normally that space is for gas exchange. But since no gas is going here or air is not going here, this will become dead space, and that is called the alveolar dead space. So now you know how the alveolar dead space is created. Make sense? So blood will go here, but since these alveoli don't have air, no exchange will occur. If it blocks here, then this whole part will become what? Dead space. Make sense? So, which one is fixed and which one can be changed? Anatomical dead space is what? Fixed, because your structure is designed that way. Which one can be created? Alveolar, right? In clinical conditions. Now if you take the medicine, destroy that block, right? Blockage, then it will become again functional. Your dead space will be gone, right? So alveolar dead space can be changed. External respiration, internal respiration. In last class, I mentioned 4 processes of respiration. Pulmonary ventilation is breathing. Now you tell me, I told you to remember very simple thing. External respiration occurs where and internal respiration occurs where? External respiration occurs in the lungs and internal respiration occurs in the tissue. That's what I told you to remember. Okay, you didn't remember. Okay, so are you taking notes? Are you taking notes? Okay, good. Okay, so external respiration occurs where? You didn't take note. External respiration, yeah, look at that. You are taking note in the phone, not in the notebook. External respiration, look at your cell phone. External respiration occurs where? In the lung. And internal? In the tissue. Okay? Good. I'll ask you again. So,
Are we ready?
you be ready?
Mm-hmm.
Okay, good. I want that. Okay. So you already know, blood goes to the lung to get oxygen. Okay. So this is the alveoli of the lung, and this is the capillary. You know that alveoli is covered by capillary. So this is alveoli and this is the capillary blood. So blood goes to the lung to get the oxygen. Carbon dioxide, I told you, this is a rule. Carbon dioxide always move same way or opposite? Opposite, right? So you already know these things. Blood gets oxygen from the alveoli. So carbon dioxide will go from the blood to the alveoli. That is external respiration. That is what happens inside the lung, right? That is what happens inside the lung. And that is the external respiration. Okay. Now blood got the oxygen. That oxygenated blood will get back into the heart, right? And left ventricle will forcefully send the blood to the body because your tissue needs oxygen. So let's see the tissue. So these are the cells in the tissue. Okay? And this is the capillary. Okay? Going to the tissue, capillary, and this is the tissue. Okay, oxygenated blood enters into the tissue. So blood goes to the tissue to get oxygen or give oxygen? Give oxygen. Okay, so you already know that. So look at me. Blood is giving oxygen to the tissue. Tissue is getting oxygen for metabolism. Carbon dioxide moves from tissue to the blood, opposite, right? So carbon dioxide will move from the tissue to the blood. Is it clear? So this is called what? Internal respiration. Got it? In last class I explained same thing. Okay? So external and internal. Now you tell me, who moves the air from or gas from one place to another? I told you the difference of pressure. Only small amount of pressure difference can move the gas. You have seen that, right? Mm-hmm. So the partial pressure, that is called the partial pressure of each gas. Now look at this. Oxygen moves from the alveoli to the blood, capillary blood in the lung. So oxygen pressure should be higher inside the alveoli. Make sense? Because from here it moves there, right? So pressure of oxygen should be higher here and lower here. That will move the gas from high to low. So inside the alveoli, the pressure of oxygen, that is called the partial pressure or PO2 of oxygen, is very high, 104 millimeter of mercury. That is called intra-alveolar oxygen pressure. How much? 104. Make sense? And inside the blood, the pressure should be low because oxygen should move from here to here. How much? Here, only 40 millimeter of mercury in the capillary blood. So in the alveoli, it is 104. In the capillary blood, only 40 millimeter of mercury. Make sense? How much difference? 64 millimeter of mercury. That's a lot, right? So that will move the oxygen from here to the blood, from the alveolus to the blood. Make sense? Okay. Now, carbon dioxide moves from the blood to the alveolus. That means the pressure should be higher here and lower here. What is the pressure of carbon dioxide in the blood here?